Today we are literally going to add a whole new dimension to your web dev skills, so you can also build 3D websites that leave everyone breathless. Three.js, the library that turns ordinary websites into extraordinary. And today we are going to master Three.js from the basics by building a retarded video player. And to take things on another level, we will also learn to add physics in our Three.js websites with Cannon.js. So what are we building is the scene that has a field, a football, and a bunch of these screens. We can move the football by clicking and dragging the mouse, and when the ball hits one of these videos, then that video starts playing. And to make things more interesting, we'll also add these stars in the background, this helicopter that contains an animation. So basically by the end of this video, you will know almost everything required to build stunning 3D websites. This is a complete beginner tutorial, so if you have worked with HTML, CSS and JS even a little bit, then you are ready to build this project with me. So now let's get started. So we will start by creating a project. Now you can definitely just use HTML, CSS and JavaScript and start working with that. But I'm going to use white to create the project because with white we will be able to, manage dependencies easily. So run the command npx create-white and the name of your project. I'm going to call this retarded video player. And we will use the vanilla framework, so hit enter. And we're not going to use TypeScript, so just select vanilla, hit enter. Now open the folder in VS Code. With Windows, I can just type the command code and the name of my folder, and that will launch the folder in VS Code. Now first, let's get rid of things that we don't need here in the left panel. I'm not going to use this style.css. We will be using very little CSS, and I'll just add it in the HTML. So remove this file. This counter.js that comes with the white project, delete that. We don't need this JavaScript svj, wheat.svj, delete. And in main.js, get rid of everything. And now in the index.html, we don't need anything in the header. Okay, maybe a title that will display the name of our project. And I'm also going to remove this div from here. Don't need it. Let me just zoom things in a little bit so things are clearer. Okay, now I want you to install the Three.js dependency. So open up the terminal, Ctrl J, and run npm i3. Now in my HTML above this script, I'm going to add a canvas. This canvas is going to render all our 3D scene, and I'm going to give this an ID so I can easily identify it in my JavaScript file. Let's call this scene. And inside the head, I'm going to add some CSS. So add the style tag. And here for the canvas, I want it to be fixed. And I'm going to pin it at the top left corner. So top 0, left 0. Now go to main.js. And here we are going to start by importing the 3 library. So import everything as 3 from 3. Okay, so Three.js project needs 3 things: a scene, a camera, and a renderer. The scene is where all the magic happens. We put everything in there, all the 3D models, all the animations, everything happens in the scene. And the camera basically controls what part of the scene to display. And the renderer basically renders the scene from the camera's perspective. So let's not make things complicated and start by creating an object of scene. Const scene equals new 3.scene. And now we need a camera, so let's create a camera object, new 3. Now there are a bunch of cameras, but the 2 most important cameras, the 2 most useful cameras that I have seen is the perspective camera and the orthographic camera. And from this, the perspective camera is used the most. It lets you mimic what your eyes see. So let's have a perspective camera here. And we need to pass a bunch of parameters here. The first parameter is an angle, and this is the field of view. And typically we set the field of view to 75 degrees. And after the field of view, we pass the aspect ratio. This aspect ratio is the aspect ratio of the window where all the scene is being displayed. And we can get that aspect ratio by dividing the inner width of our window by its inner height. Next, we have something called as the near point, and this is a distance. Typically the number is 0.1, And this means that anything which is closer than 0.1 units to the camera, then that thing will not be rendered. So if you want your objects to be rendered, then it should be at least 0.1 units away from the camera. And the last parameter is the far plane. And the number we are going to use here is 1000. So this is also a distance, and anything which is farther than this distance will not be rendered by the renderer. And then we need a renderer that is going to render the camera and the scene. So a new 3.webgl renderer. And in here, I'm going to pass the canvas where the rendering is supposed to happen. So this is going to be the canvas we have in our index.html. And we can get that by its ID, which is a scene. And now we'll have to set the pixel ratio of the renderer to be the same as the device's pixel ratio. And we also need to specify the size of our renderer. Right now, we do not know how big the canvas is going to be. And we can set that with the set size function. The width is going to be window.inner width and inner height. With Three.js, we can get our 3D models in a couple of ways. The first way would be to use default shapes available in Three.js and then just render that. And another way would be to import a 3D model that you can find on websites like Sketchfab, or you can make your own 3D models from Blender. But of course, in this project, we are going to use 3D models that I have downloaded from these websites. So yeah, you can create 3D models from the default shapes that are available in Three.js, like a sphere, a box, a cylinder, a torus, and all that. Or you can just import a 3D model. So right now, let me show you how to create a sphere and add it to our scene. So to create 3D models with the shapes available in our Three.js, we'll need three things. The geometry of the shape. So here I'm going to need a sphere geometry, which I can get by calling new 3.sphere geometry. The first parameter here is the radius of the sphere, and the next two parameters are the width and the height segments. Basically, the width and the height segments control how smooth your sphere is going to look. And I'm going to set this to 60,60. After a geometry, we need a material. This material is basically going to wrap over the sphere and give the sphere some actual look. So I'm going to create a sphere material from new 3.mesh basic material. We have a bunch of materials available. A basic material does not require any lighting. So whatever color we provide to this material, that will be easily visible. But if we use a standard material, then this is light dependent. So it will only show up the parts that are being lit up by a light source. We will talk about light source later in the video. But for now, let's just use a basic material, so we don't have to worry about the lights. And here I can specify the color of my material, and let's just make it orange, the name of the color, or I can also pass a hexa value. And once we have a geometry and a material, we need to club these two together. We need to wrap our material on the geometry, and that we call a mesh. So a mesh basically takes a material, takes a geometry, and wraps it together. That can be then added to the scene. Pass the geometry and the material to the mesh. And now to add the mesh to the scene, we need to call scene.add, and here we can pass the mesh. Now, if I go ahead and run this now, then nothing is going to happen because we haven't rendered the scene. And to render the scene, we call a renderer.render function, and here we pass the scene and the camera that has to be rendered. Okay, so now let's go ahead and run what we have on the scene. npm run dev, and we see nothing on our scene. That is because our camera and the sphere are both on the center point. They both are on the same location, and the camera is not able to capture the sphere. So what I'm going to do is move the camera a little bit so it can see the sphere mesh. And I can change the position of the camera by calling camera.position, the set function on it. I'm not going to move the camera anywhere on the x-axis, nothing on the y-axis, but on the z-axis, I will move it by 5 units. And here this looks like a circle and not a sphere because we are using a basic material, and a basic material is going to equally show the orange color everywhere. But with a standard material, we could have seen the depth of the sphere with a light source. But that's okay. We will go into lighting a little bit later into the video. For now, I'm going to set the wireframe for this basic material to true. And this will give us a sense of depth. And I guess the sphere has too many width and height segments and it looks a little cluttered. So I'm going to reduce the segments from 60 to 32. Now a Three.js project is basically nothing without animations. So let's see how we can animate this sphere. So I'm going to create a function animate. And here I'm going to rotate this sphere. And doing that is very simple. I can just call sphere mesh.rotation and then I can update the X, Y and the Z values based on what kind of rotation I want. And I'm going to add 0.01 here. This means 0.01 radian. So if I set this to, let's say, math.pi/2, then this would rotate the sphere on the x-axis by 90 degrees. But I don't want to rotate that fast. I'll just set it to 0.01. Now I'll also make it rotate on the y-axis. And then I'm going to call the animate function. But this is obviously not going to do anything because the animate function needs to be called in a loop. So with every call, the sphere will rotate by this much. And I'm not going to just directly call the animate function like this. That will create a lot of issues. We are going to use the request animation frame function. And then here I'll pass the animate function. What this is going to do is this is going to match the frame rate of your device. So let's say if your device is handling 60 frames per second, then this function will try to match that. And now let's save and see what is happening. Nothing happened. That is because whenever there is any change in our scene, we need to re-render it. So we will have to move this call to the render function from here to the animate function. And now this should rotate our sphere. This looks great and amazing or whatever. But one more thing, if I now change the size of my window, then you can see the canvas does not resize and that does not look good. So we'll have to reconfigure the size of our renderer after the window has been resized. So I can look for any resize events on the window with the onResize callback function. And in here, what I'm going to do is set the size of the renderer to be equal to the new size of the window. And the change in the size of the window will also need an update for the aspect ratio of our camera. So let's set the aspect ratio of our camera to inner width by inner height. And then we will have to call the camera.update projection matrix for the changes to take effect. And now if I resize my window, then that will reconfigure the size of the renderer and the camera's aspect ratio. Okay, now before we go ahead and build our actual retarded juicy stuff, I will also want to tell you about the basics of Cannon.js and how to add physics with Cannon.js. So open up the terminal, press Ctrl J, and here we are going to install the Cannon library. But I'm not going to use the original Cannon library. I'm going to use the Cannon.js library. This is a fork of the original library. It comes with many more features that are essential and makes it much more easier for us to add physics in Three.js. So we will need Cannon.js, and along with Cannon.js, we will also need this Cannon.js debugger that will help us set up our physics world easily. Without the debugger, it will be a little difficult. So install these two libraries. And now in my main.js, I'm going to get rid of this sphere. We don't need this sphere. Let's see how to work with Cannon.js. So remove that, remove this. So here we need to import the Cannon, and we will do that with import everything as Cannon from Cannon.js. And let's also import the Cannon debugger. Okay, so to add physics with Cannon, the first thing we need to do is create our physics world. So here I'm going to create a variable called world, and this will be an object of Cannon.world, and we can configure how our world is going to behave with these properties. But for this, I just want to have gravity in my world. I want gravity on the y-axis downwards. So I'll pass a Cannon.vector3 object here. On the x-axis, I don't want any gravity. On the y-axis, I want -9.82. this is what the value of gravity is on Earth. So let's use that. And on the z-axis also I don't want any gravity. And now any physics element we create will get added to this world. So let me just create a ground body that will represent our surface, and everything will fall on this surface. So let's create a ground body, and this will be an object of Cannon body. I want the mass of this body, this ground body, to be 0. Why 0? Because if I pass the mass as 0, then this body will be static. So if it suffers any collision from other objects in the world, then it won't move. It will be static and it just won't move. And that's what we need for our ground. We don't want it to move when the football falls on it. We will also pass material, and this will be Cannon.material, ground material. But right now it is just a normal body. It does not have any shape. We need to add shape to our Cannon body. The shape could be, let's say, a plane, a box, a sphere, a cylinder, and all that. But for our ground, we need a plane. So the shape here will be Cannon.plane. And now we can add our ground body in our world. We haven't specified any position for this ground body, where to place it in the world. So by default, it will put it at the center, which is 0, 0, 0. We can also change the position based on how we want it to be. We will look into that a little bit later. Now let's run and see what we have on the scene. And right now we do not see anything on the screen. So to be able to see stuff on the screen, we will need to use the Cannon debugger. The Cannon debugger lets us visualize what is happening in our world, so we can set up our scene easily. And how are we going to use it? Well, we are going to create an object called Cannon debugger, and here we need to pass the Three.js scene where the debugger is going to render the world bodies, and the second object is our Cannon world. And now in the animate function, we just have to call Cannon debugger.update. And we see something over here. But what the hell is this? Why does our plane look like this? That is because our plane is currently vertically placed. I am going to rotate this plane by 90 degrees so it is flat, horizontally laid down. And I can rotate my Cannon body by calling groundbody.quaternion set from Euler. And here we need to pass the angles where we want to rotate. So I only want to rotate it on the x-axis by -90 degree. So math.pi by 2, and on the other axis, the rotation will be 0. And now we see a line. Why is that? Because the camera is directly facing this plane. We have moved the camera 5 units from the center on the z-axis. If I also move it on the y-axis, then we can see the plane. Then we can see the plane properly. Let me also move it on the z-axis a little bit. But again, the camera is not looking at the place where I want it to look. So we can control where this camera is supposed to look at by calling the look at function on the camera. And I want the camera to look at the center. So I can just pass 0, 0, 0. Now if you have interacted with Three.js websites, then you can see that we can interact with the Three.js world with our mouse. So if we click and drag, then the scene will rotate. We can zoom in, zoom out. We can do all that with something called as orbit controls. So let me add orbit controls so we can check out our scene by dragging the mouse and everything. I'm going to import something called as an orbit control. Import orbit controls, and this is in 3/examples JSM/controls/orbit controls. And now let's create an object of orbit controls. Const controls equals new orbit controls, and here we need to pass our camera, the Three.js camera, and the HTML element where the thing is being rendered. So basically this is going to be our canvas, and we can get that from the renderer.dom element. And now we can interact with our scene. By the way, for the controls to behave even better, on the animate function we also need to call controls.update. And with calling controls.update, we don't need to call this camera.lookat. It automatically does that for us. Now that I have a ground body over here, let me add a sphere that will fall on this ground. So here, create another Cannon body. I'm going to give this sphere some mass. The shape is going to be Cannon.sphere. And here I need to pass the radius of the sphere. Let's go with 0.5. Let me add a material to this body. And I don't want the sphere body to stay at the center initially. I will give it some height so it can fall from there on this plane. So position will be a new Cannon.vector 3, and on the y-axis I'll lift it up by 10 units. And now I can add this to my world by calling the add body function, but it doesn't do anything because the physics is not being calculated. To calculate the physics in the animate function, we'll have to call world.fixedStep. And we see some physics going on over here. Okay, so now that we have gone through the basics of Three.js and Cannon.js, let's start building our video player. I have added these resources in the public folder. I have a football, a helicopter, a stadium, and a bunch of videos. I got these 3D models from this website called Sketchfab. There are a bunch of good websites from where you can get 3D models for free. So if you're building something, then you can refer to these websites for resources. Most probably you will find what you need. But if you don't find it, then you can always build your own 3D models using Blender. So just go through a 10-hour tutorial for Blender and build it yourself, or just download it from these websites for free. You can find these resources in the GitHub repository that I have put a link to in the description. So just add these things here in the public folder and let's go ahead. These models are in the GLTF format, and in Three.js we have something called as a GLTF loader. So we can use that loader to import that 3D model. So import GLTF loader from 3/examples/JSM loaders GLTF loader. And now here I'm going to create an object called GLTF loader. And now to load any model, I just have to call the load function, and here I have to pass the path of my model. It is located in the stadium/scene.gltf. This is the first model that I'm going to import. Stadium/scene.gltf. And then this will return us the model. And we can simply add this model to our Three.js scene by calling scene.add gltf.scene. So looks like our model is added over here, but it is completely black. We cannot see anything. That is because there are no lights in this scene. So we need to light this up. Now there are a bunch of ways to light the scene in Three.js. There's this thing called as an ambient light that lights up everything in the scene equally. So create an object of that, new m3.ambient light. The first parameter here is the color of our light. I'm going to use a white light, so 0x for a hexa value. And the second parameter is the intensity of the light. So if I make it, let's say 100, then nothing happened because we need to add it to the scene obviously. So scene.add ambient light. And making it 100 is going to make it too bright, so I'll use 1. Now it is still not completely lit up the way I want it to be. So now I'm going to add something called as a directional light. A directional light lights up the scene in a particular direction, much like the sunlight. So along with the ambient light, if I add the directional light, then I think our scene will look much better. You'll always have to experiment with the lighting to see what works good on your scene. Yeah, let's get the directional light over here of color white. And intensity, let's see 1. And I'm going to add it to the scene. I'll also lift it a little bit. So I'll change the position of this directional light, and I'll set it to be 10 units on the y-axis. It doesn't do much, I guess. So let's try increasing the intensity of this light. And yeah, I guess this is quite good. Now, other than this, we also have a point light, which is like a light bulb, you can say. So yeah, whenever you need lighting, just experiment with a bunch of lights available and you will just find the right one for you. I think the stadium is a little too small. I want to increase the size of this stadium. So first I'm going to change the scale of this stadium in this, and then I will add it to the scene. So let me just create a variable stadium. This will be referring to the gltf.scene, and I want the stadium to be 2x of its current size. So let me just define a scale that holds the value 2, and then I can set the scale to 2. But this is not in the center. This stadium is not in the center, so Let's try moving it to the center. Now you'll obviously have to manually move this stadium by changing the value of the X, Y, Z coordinates. And I have tested the values, and the value that puts it into the center is 23.5 on the X, -1.1 on the Y, and 45 on the Z. I'm moving it down on the Y axis so that this is right where the plane is. So if the sphere is falling on it, it should look like that it is falling on the surface of the sphere of the stadium. So doing this is also not just enough. We also have to rotate this by 90 degrees. And then that will put it in the center. Again, you just have to manually figure out these models that you load, how to place it and how big it should be. Okay, so let's rotate this stadium by 90 degrees on the Y axis, and I think that will do it. So stadium.rotation.y equals math pi by 2. And now we are in the center. Now let's add the football into the scene. So again, I'm going to do the same thing. gltf loader, load football / scene.gltf, and then that will return me an object through this callback function. And let me just add it to the scene and let's see how it looks. Okay, this football is too huge. It is bigger than the stadium, so let's decrease its size. Let me first create a football variable, because we are going to need this model outside of this function. So, and football equals gltf.scene. The scale that worked for the football is 0.003. Right now it looks weird, but that's okay. The way we transfer physics from Cannon.js to Three.js is that whatever is happening on the Cannon body, we just copy the position and the rotation of that to our Three.js object. And then it looks like the physics is happening to the Three.js object. So what we need to do is we need to make this sphere to be the same size as this football. And then we will just copy the rotation and the position of the sphere to this football, and then the football will look to have physics in it. So first, let me reduce the size of this sphere. I'm going to change it from 0.5 to 0.13. And now I'm just going to copy the position and the rotation of the sphere to the football. And I need to do that in the animate function. So here I'll see if the football exists, because the loader.load function will take a little bit of time to load the model. And during that time, the football will be null, undefined, and if we just don't do this condition thingy, then the thing will crash. Okay, now here I just have to copy the position. So football.position.copy sphere body.position, and I also want to copy the rotation of the sphere body to the football. So football.quaternion is to copy the rotation, and here we need to pass sphere body.quaternion. And let's also make the camera follow the football, and I can do that by calling camera.position.copy sphere body.position. But what the hell? Looks a little bit weird. That is because the camera is exactly inside the football, and that will make it look weird. So let's add a little bit of offset to this. So first it will copy the position, and then it will move itself a little bit from that position. So I'm going to create this variable called camera offset, and this will be a new 3.vector3. On the x-axis, I don't want any offset. On the y-axis, I'll move the camera up a little bit by, let's say, 0.5. On the z-axis, I will move it by 1.2. And then I will simply add this offset in here. And this looks a little better now, I guess. And I'm also going to get rid of this orbit controls now, because we don't need this for this project. I'll also get rid of the import statement. Now for the current size and mass of the sphere, this football is not bouncing. It doesn't look authentic. And to control how this sphere body is interacting with this ground body, we need to play with the restitution property of the material. So here I will change the restitution on the ground body material to 0.8. It still doesn't do anything because we also need to play with the restitution value of the sphere body. And for the sphere body, I want the value to be 0.5. Okay, so this is nice, but the ball looks a little unnatural because it is just falling flat on the ground. It will look better if it had a little bit of a rotation. So we can do that by giving it some angular momentum, angular velocity. So I'll add some initial angular velocity to the sphere body, and this will be new Cannon vector 3. And I'll give it some velocity on the x-axis, nothing on the y and z. But now it has created an issue that the ball is just moving, it is not stopping. This is happening because there is no damping in its motion. So whatever velocity we gave to it, that is not reducing. We can fix that by adding some linear and angular damping to the sphere body, so it will stop moving after a while. So here add linear damping. I'm going to set the linear damping to 0.2 and I'm going to set the angular damping to 0.5. This is just slowly going to reduce the movement of the ball. Okay, so now let's add some movement to this football. So whenever I click and drag the mouse, I'm going to add some velocity to the football in that direction. And for this, I need to know when the mouse has been clicked. So I'll add an event listener to the document, which is mouse down. And when this event occurs, I just want to note down the x and y values. X will be equals to event.clientX, y is client y. And now when the mouse up event is registered, then here I just want to add some velocity to the football. So I need to know how much the mouse has moved on the x-axis, the current position of the mouse minus the old position, and dy equals this. And now that we have this information, we can add velocity to the football. So sphere body dot velocity dot set, and on the x-axis I'm going to set dx. On the y-axis, for now let's just put it to 0, so it's not going to move up in the air. Z-axis, I'm gonna make it dy. Let's test this. Oh my god, there are a bunch of issues here. First of all, the ball is moving in the opposite direction. So let me just add a negative sign over here, and now it should move in the right direction. Yeah, but it is moving a little too fast. So let's reduce that as well. So I'm going to have a variable called velocity factor, and this I'm going to set to 0.015, and I'm going to multiply this velocity factor to the dx and the dy. And now I guess the speed is good enough. One more thing I want to do, the ball should also gain up some height. For that, I'm just going to get the magnitude of the drag, and based on that I will add some height to this velocity. So create this variable called magnitude, and we can get the magnitude by just getting the square root of dx square plus dy square, and just pass this magnitude. And I'll also multiply the velocity factor so that it doesn't go too up in the air. And now if I give it some velocity, then the ball goes up in the air. Now there's going to be another issue, that if I get the ball up in the air and then I drag the mouse again, then it's just hopping in the air. Like what I need to do is, I only want to apply velocity when the ball is near to the ground. So that I can do by checking if sphere body dot position dot y. If the y position of the sphere is lesser than 0.3, then only I want to apply this velocity. It is only going to gain velocity when the ball is actually near the ground. And now one more issue is there, that I'm able to pass through these nets of the football field, but I don't really care about it. I mean, if that annoys you, then what you can do is add some planes, some ground bodies around the football field. But it doesn't really matter that much to me, so I'm not gonna do that. Okay, we have a lot more code to write, and I don't want to clutter the main.js file by putting everything over here. So before I go ahead and do some more stuff in here, I am going to extract this football and the stadium code into their separate files. I'm going to create a folder called objects, and inside this folder first I'll create this stadium.js Three.js, and in here I'm going to paste all the code required to render the ground body and the stadium model. So write this function create, and this function will take 3 parameters: scene, the Three.js scene, the Cannon world, and the loader. This is the GLTF loader that will load the 3D model. And then I'm going to export this function, and in the main.js import that stadium, and here below the GLTF loader.load I'm going to call stadium.create, pass the scene, the world, and the loader. And I'm just going to cut paste all this code inside my stadium.js. So let's get rid of this ground body. This is the plane, paste it over here. We will have to import the Cannon library so we can access all those things. Import everything as Cannon from Cannon.js. And what else? We need this thing. Get rid of that. Paste it in here. And replace GLTF loader with loader. Let's save this main.js, and we have an error. Loader is not defined. Where is that? Okay, sorry, this is GLTF loader. And we have extracted the stadium. Now let's do the same thing for the football. So create football.js inside objects. And here first I'll import everything as 3 from 3 because we'll need this library, and we will also need the Cannon. So now for the football I'm going to have 2 functions that will be exported from here. First will be the create function, and the create function will take scene, world, and loader as parameters. And I'll also have this animate function, and the animate function will take the camera as an argument. So we can reposition the camera based on how the football is moving. And we will just export these 2 functions from here. And now in the main.js import the football, and below stadium.create I'm going to call football.create, pass the scene, world, and the GLTF loader. And now we'll just cut paste all the code for this as well. Take all this code, go to the create function, add it in here, and the sphere body will be required in the animate function as well. So I'll give this a global scope. And what else? This GLTF loader.load, take this out, go to the create function, change the GLTF loader to loader. And this football will also be a global variable. And in the main.js, this football variable is not required. And now in the animate function, what I'm going to do is call football.animate, pass the camera, and then just take all this code and paste it in here. Again, the camera offset is a variable that is over here, so take this out as well and paste it here. Let's save the main.js and see if it is working. But issues, we are not able to move the football because we also have to take all this code and paste it in there. So go to football.js, paste it below the animate function, and now we have extracted both the things. Okay, now we are going to create the screens that will be rendering our videos, and I won't do that in the main function as well. For that also I'll create a new file, and I'll name this file screens.js. And let me get all the imports that we need. We need 3, we need Cannon. If you open the Explorer and go to this public and video folder, you'll find these bunch of videos that I have added. You can get this in the GitHub repo. And along with that, you can also see this videos.json that has the link and the title of every video. So we need to import this JSON in our file. And I can simply do that by calling import video, and I'm going to name this video sources, and this I'll import from videos.json. So double dot to go to the previous directory where this file is located. Okay, so for our screens, we need a bunch of constant values. So we have this array that is going to store every screen that we have rendered into the scene. The row size is how many screens we want in one row. And this is the video width and video height. This is 16 9 aspect ratio. And we will also give some thickness to the video screen, so it gives it a little 3D touch. After that, we have these constants. So these offsets are nothing but I don't want to render the screens in the center of the field. I want to displace it a little bit. So on the x-axis, I'm moving it by -6 distance units, z -4.2. And on the y offset, I am doing it video height plus 0.1, because if I don't move it up by the video height, then half of the screen will be below the stadium. We'll see how it looks without this y offset, so you can understand what this thing is doing over here. And then finally, we need these three. The spacing is nothing but how much space we need between two screens so that they don't look everything touching together. And then we have video width and video height in 3. So basically, the size of a box in Cannon.js is twice the size of a box in Three.js. So we just have to multiply the width and height with 2 so that we get the correct size in Three.js. This is nothing to worry about. You always have to multiply it with 2 when it comes to sizing boxes in Cannon and 3. And this file will have this create function. And the create function will take the scene and the world as parameters, and we will just export this function. This is all the export we need from here. So what I'm going to do here is create a bunch of screens, add those screens in this screens array, and then return that screens object from here. So basically I'll create a loop and I'm going to create 12 screens, and then in every loop I'll create a screen and add it to the scene. But I won't do it directly in the create function. I'll create another function for that. I'll name this function add screen, which will take the scene and the world as a parameter, and I'll simply call this add screen function inside this loop. Okay, so the first thing we need here is the position of our screen. Where do we need to position it? So I'm going to create this variable row position, and this will be equals to screens.length mod 4. Instead of mod 4, I'm going to use the row size variable. So this will basically make sure that there are not more than 4 screens in one row. So the row position will vary between 0, 1, 2, and 3. And then we need the column position of our screen. So this will be screens.length divided by row size. And I need to convert this into an integer to get rid of any errors. I'll use the math.floor function to do this. This is basically nothing. For the first 4 screens, the value of the column position will be 0. And from 5 to 8, the value of this will become 1. So the column position will increase if we have reached the maximum number of elements in one row. And now I'm going to create a Cannon body that will represent our screen. And the shape of that will be a box. So create this Cannon.box and pass these dimensions inside this box, the video width, height, and the thickness. And now we'll create the Cannon body. So create this screen body, which is a Cannon body. The mass is set to 0 because I don't want the screen to move when the football hits it. I want it to stay static. And the shape is this box. And let me just add it to the scene to see what is happening. So I'll call world.addBody screen body. And nothing is happening because we need to call this function. So go to main.js and import that screen. And below the football.create, I'll call screens.create, pass the scene and world, and we have our thing. And we're only seeing one object because everything is positioned in the same place. So we need to position these elements based on our row position and column position. So let's call screenBody.position.set. So on the x-axis, the position is going to be video width 3 into row position, not video height, video width. We're using video width 3 because the size of this box is twice the normal size. That's a little bit of issue with the Cannon.js boxes, so we just have to use this. And video height 3 into column position will be on the y-axis. And on the z-axis, for now, I'll set it to 0. And again, everything is still in the center because the screens.length is always 0. We are not adding our screen into this array. So let's add that screen body in the screens array. So call screens.push. And in here, I'm going to push an object which will have a property body, and this will be the screen body. And now we have our videos rendered but everything is in the center and everything is just cluttered together. So first I'm going to move it back a little bit so that the football doesn't fall on it, and I'm going to add the Z offset instead of 0 over here. It has moved a little bit, but it is still very close to the football. So what I'm going to do is move the football a little bit back. So go to the football.js, and here for the position of the football, I'll add 2 to the Z axis of the position. Okay, that is good. Now go to the screens.js, and I want all these frames to be centered kind of. It's a little too off on the right side. So let's move it a little bit on the X side by adding this this X offset, and you can see this the first row is below the screen, so you can't see all of it. So I'll also add the Y offset over here, and lastly let's add some spacing between these screens. So instead of multiplying the row position and column position with video width and video height, I'll also add the spacing over here, and now it looks a little better. Okay, so now our task is to load the videos from the video sources and render it on the screen. I'll do that in a separate function. I'll create this function named getVideoObject, and this will return a Three.js video object. And this is going to take the scene as a parameter. Our videos are stored in this object, which is an array. So first we need to get the index of our video, and that is nothing but screens.length. In the videos.json file I have 12 videos, so running this thing 12 times will not give me any error, but you'll have to make sure that this number is same as the number of videos you're trying to render. So first thing I need to do is create an HTML video element, and then I'll create a texture out of this video element, and then I'll render that texture on a Three.js box, and that box will be positioned at these Cannon bodies. So call document.createElement video. The source of the video will be video srcs index I, and I also want to add the title to the dataset so that I can access it later. And now I'm going to create a Three.js video texture out of this video. So create this video texture variable. This will be new 3.video texture, and here I have to pass the video element. And we will also need to add these 3 lines to properly match and render the video on different resolutions. These are not very important, but you can just look what they do on Google. It's not that important. And now we can create our Three.js box. And to create a Three.js box, we need a geometry, we need a material, and then we'll club it together with a mesh. So create a geometry. This will be a box geometry. The width will be video width 3. Height will be height 3, and for the video thickness, let's use this and multiply that with 2, because I didn't create a 3 variable for that. So we'll have to multiply it with 2 to match it with Cannon.js box sizes. And now we can create our material. So material equals new 3, and I'll just use a basic material. And in here, to render the video, I can set the map to the video texture, and now the video will be playing on the material. And finally I can mesh it together, and now we just need to add the surface to the scene, and then from here I'll return the video object and the surface. We'll need this later. And now in my add screen function, I'll create this video object, get video object, and then I'm going to position the Three.js object as at this screen body. So just call video object dot surface dot position and copy the screen body position over here. And inside the screens, I'll also push the elements of this video object. So just 3 dots and video object, and it will copy those things in here. And the thing has been rendered. Okay, so now our task is to detect any collision between the football and these video objects. And once detected, play that particular video. So go to football.js, and here I'm going to create this new function called setup collisions, and this function will take the screens as a parameter, and I will also extract the setup collisions function from this file. And in my main.js, I will call that function football.setupCollisions. We need to pass the screens, and that screens is getting returned by our this create function. So just create this screens variable and pass this in here. Now go to this function, and here to detect any collision between the football and any object, I can just add this event listener. It's called collide. And in here the first thing we need to do is get the object with which this football has collided. And that we can extract from this event. So this body is going to be a Cannon body. And now our task is to make sure that this collision only occurred with the screens and not with the plane. If it's with the plane, then we're not going to do anything. So we are going to go through each of the screens in our screens array, and we'll check if the screen body is same as this body. If it is, then we are going to get that. And then I'll check for this condition. And if our screen is not defined, then we'll return from this method. So this will basically get the screen with which the collision has occurred. And if the collision did not occur with any screen, then this will not be defined. And we will return from this method. Now I also need this variable current screen. It will keep track of which video is currently playing. And then I'll check if the current screen is same as this screen. So if a video was playing and we hit that video again, then we want to pause that video. So in our screen object, we have our video element. We push that over here. This get video object is returning that video, and we are pushing it to the screens. So here in the football.js, we're checking if the video is paused. If the video is paused already, then we will play it. Otherwise, we'll pause it. And then we will return from this. Otherwise, our current screen will be equals to this screen. And then we will play the video which was hit. So const, I'll get the video element, and I'll just call video.play. Let's see what is happening if we go and play it. I'll go play this. Oops, nothing is happening. Why is that? Nothing is happening because we need to add the event listener not to the document, but the sphere body obviously. Now let's go ahead and try playing that video.
Stop it.
The video
Get some help.
Playing. And if I hit another video, then that video starts playing as well. So what I need to do is, when a new video starts playing, I need to stop playing the previous video. So what I'll do is I'll check if my current screen exists, and if it exists, then I'll stop playing that video. So I'll get the video element from the current screen and I'll pause it. And now if a video is playing already and then I hit another video, then the previous one should stop and the new one should start playing. So I'll hit this.
Stop it.
That video
Get some help.
And now let me hit another video. Then that starts playing and this one has stopped. Alright. Now we don't need this Cannon debugger anymore. We have set up our scene. So let me just get rid of these green lines. And to do that, let's just go to this animate function in the main.js. Remove this line. Remove this line as well. And we also don't need to call this camera.position.set because the camera is following the football. So this is also not required. Okay, looks much cleaner. Okay, now what I want to do is, when a video starts playing, then I want to highlight that video. So I'll add some kind of a border around it. So go to this screens.js, and in the get video object function, I want to add a border around these elements. In here, I'll make a call to this add border box method, and I'll pass this surface where we want the border. This is not a function that already exists. We need to create this function. So here I'm going to create a box geometry from 3. The width and height is going to be the same, but I'm adding this extra 0.1 so that it is a little bigger than the video screen and it is visible around it. And for the thickness, I'm not multiplying it with 2, because if the thickness is same as our screen, then this border will come in front of the video and it'll look weird. Now we need a material for our border, and I'll use a basic material. I'll set the color to red, and then we'll create a mesh out of this. And finally, we need to add this mesh to our scene, and we don't need to call scene.add to add it. If we do that, then we will have to position the element to where our surface exists. To avoid all that, I can just call surface.add, and here I'll pass this border mesh. Now what this is going to do is this border mesh will become a child of this surface and it will automatically position where this surface exists. And now we have added a border around it. We only want this border to be visible when the video is playing. So for now we'll make everything transparent. So I'll set the transparent property to true and then I'll change the opacity to 0. So this will allow our material to be transparent and this will set the opacity to 0. Now we'll go to the football.js and when a video is playing, we'll change the opacity to some value. I'll create a function that controls the opacity of those borders because we will be needing that multiple times. So just add this function update box opacity. It takes the surface and the target opacity, and our border box is a children of our surface and we only have one child, so it will be located at the 0th index. We are getting the material of that border box. We are setting the opacity to our target opacity, and then we are telling Three.js that our material needs an update. Okay, so now when a video is playing, then we need to display the border around it. So along with the video, I'm also going to extract the surface from the current screen, and then I'll call the update box opacity method. Here I'll pass the surface and I'll set the opacity to 0.5. Now let's go ahead and play the video.
Stop it.
And
get some help.
We have our border around it. If I play another video, let me retry, give it a bigger thing. Then that video also gets the opacity, but the old one is not removed. So now I'm also going to make a call to update box opacity over here. When a different video starts playing, I am going to remove the opacity from the current screen. So extract the surface from here, pass it to this function, set the opacity to 0.0. And now if I go play this shit.
Stop it.
Stop it.
Get some help.
Get some help. Okay. Yeah, so we get this thing, and if I play another video, then the previous border is removed. Okay, so now I'm going to put some challenges for you. I think you know enough to build the rest of the things on your own. But yeah, if you get stuck anywhere, then you can always just look for the right code from the GitHub repository. So now I want you to add a bunch of stars in the scene that will be randomly placed, and they will also appear to be blinking. And in the public folder, there is this helicopter model. Load and display it and make that heli move around the stadium. This helicopter model also has an animation on the rotors. So use ChatGPT or whatever to figure out how to play animation in Three.js. It's actually very simple. A couple of lines of code will do it. And the helicopter folder also has this MP3 sound. I want you to play this sound, and the volume of this should change based on how far the helicopter is from the camera. And I also want you to add a reset button that will follow the football. And when clicked, it will put the football at its initial position. You will need something called as a CSS 2D renderer to do this. It comes with Three.js. So yeah, I encourage you to not be lazy and do all this. Finish the project, don't leave it hanging. And if you made it so far, then you should subscribe, like, and just like support, bro. I'm too tired now. I need to go. Bye bye.